Okay, so I just want to know if these would be discrete or continuous. Remember, discrete, we said you could list the values, it's countable. Continuous, there's an infinite number of possibilities. So number of children, what's that? Discrete. Household income in the previous year. Discrete. It's most of the time, I say that decimals are continuous, but why wouldn't this have to be continuous? Right. You have a set amount, and if we're talking about income, we're talking about money, right? So there's not an infinite number of decimal places. You get paid to the nearest cent, and then they round it. So you could technically list all the possibilities. Probably wouldn't want to, but we could. Daily intake of whole grains measured in grams per day. Continuous, because you could have a fraction of a gram. All right. Now let's look at example 6. So you can't read mine very well, but I think the one on your handout I'm hoping is a little more clear. I want to know from this table, I just want to pick out individuals, variables, and then decide if each variable is qualitative, quantitative, discrete, or continuous. So if you can tell on the left, it lists countries, and then the other columns are government type, life expectancy in year, and population in millions. So what would an individual be in this? Yeah, each country would make up an individual. Okay, what are the variables? The things we're collecting information on. There's more than one this time.
Life expectancy and population.
Life expectancy, population,
Government type.
and government type. Okay, is government type qualitative or quantitative?
Qualitative.
Qualitative. Deals with the characteristic. Life expectancy, qualitative or quantitative?
Quantitative.
And if it's quantitative, we can also say discrete or continuous.
Continuous.
Continuous. You know, we can have a decimal portion. You don't have to live a year exactly. Population, discrete qualitative or quantitative? We're measuring
Quantitative.
in millions, so that's quantitative. Okay, can you have like a decimal part for a person?
No.
No. So this would be discrete. Any questions on that? The last thing in this section, and I think that's on your definition handout, we have different levels of measurement. This is probably the piece that is the most confusing out of here. So it's when we're talking about the variables, and I won't stress this a lot. We'll maybe have a question on test or quiz about it. There are 4 different levels of measurement you can use when you're talking about the variable. A nominal level is only talking about like a name, label, or category. So nominal is just giving basic information, male or female. Something very basic. then each of these build on the previous one. So an ordinal has the properties of nominal, but they can be ranked. So an ordinal is also some kind of name, label, or category, but you can rank them in some way. Interval is a step further than that. The differences have meaning. So if I subtract two of them, that has a meaning. And ratio has all the properties of those, but the ratios of the values have meaning. So I'll give you some time to write that down and then we will talk about them more. So a study was conducted to assess school eating patterns in high schools in the United States. The study analyzed the impact of vending machines and school policies on student food consumption. A total of 1,088 students in 20 schools were surveyed. Determine the level of measurement of the following variables. So the number of snack and soft drink vending machines in the school. So look at your options. Nominal. Everything is at least nominal. So we just have to kind of go through the list. Can it also be ordinal? If I'm listing how many vending machines there are, can you rank those? Okay, put them in numerical order. So it's at least ordinal. Interval. Do the differences have meaning? The high school has 2, the middle school has 5. Does it have meaning? Interval says if you subtract them. So does it have meaning to say we have 3 more in the middle school than we do in the high school? Yeah, that has meaning. So that's interval. Okay, ratio. So if we have 2 and they have 5, if I put those in a fraction, saying we have 2/5 of what they have, does that have meaning? Yes. So this one is actually ratio. All of those pieces had meaning to them. Whether or not the school has a closed campus policy during lunch. Okay. So it's at least nominal. Guaranteed. Can we rank it? No, it's yes or no questions. So can you put those in order? No. So if it's not ordinal, it's not anything else, we get to stop. This one is just nominal. Okay, class rank. We know it's at least nominal. Ordinal. We're talking freshman, sophomore, junior, senior. Can you put those in order? Yes. Okay, interval. Do their differences have meaning? Saying senior minus freshman, does that mean something? No. So this one is ordinal. Number of days per week a student eats school lunch. So it's nominal. Ordinal, can we put it in order? Yes, if we took everybody's number, we can put those in order. Interval. If Montana eats once and Connor eats 3 times, does it have meaning to say he ate 2 more times than she did? Yes, that has meaning. Ratio. So she was a 1 and he was a 3. Saying she ate 1/3 the number of times he did, does that have meaning? Yeah, so that one is also ratio. Okay, let's talk through a few more. I'm just going to pull some from the book and we'll decide what they are. Just talking through them. If I said gender, what do you think? Gender Gender is nominal. Ordinal, can you put those in order? No. So gender would just be nominal. That's it. If I said temperature, so it's nominal, ordinal, can we put temperatures in order? Okay, interval. If we subtract two temperatures, does that have meaning? Yes. Ratio. Okay, if it was 95 yesterday and 96 today, does it really have a meaning to say 95 over 96? No. So that would just be an equal. Number of days you studied in the past week. So, nominal. Ordinal, can we put it in order?
Yep.
Okay, interval, if we subtract them, does that have meaning? Okay. Ratio. If Mackenzie studied twice and Lexi studied 4 times. So if I said 2 out of 4, you studied half the days she did, does that have meaning? Yeah, so that would be ratio. Letter grade that you earn. So is that nominal? Interval, can you put the letter grades in order? Interval, does it make sense to say a C minus an A? No, so it would just be ordinal. Does that make sense to everybody? So that is the end of section 1. I'm going to go ahead and start the next piece. Our timing is a little off, but we'll kind of get back on a normal schedule here in a few days. But just moving ahead, I want to talk about section 2 now. Okay, so on your notes, I lumped sections 2 and 3 together. Does everybody in here have a Chromebook at this point? Is there anybody that still doesn't? So probably won't get to it today, but there will be something we need to do on our graphing calculators. So I just want to make sure we all have one. All right. So what we are talking about now is the difference between an observational study and a designed experiment. Those are the 2 ways that we might go about collecting information. And so I really just want to start with an example. It's on your example handout. There's really not a lot to do here. It's just a scenario. So we have researchers that wanted to investigate cancer risk among Danish cellular phone users who were followed for up to 21 years. So to do so, they kept track of 420,095 people whose first cell phone subscription was between 1982 and 1995. In 2002, they recorded the number of people out of that who had a brain tumor and compared it to the brain tumors in the general population. And they found no significant difference. So they concluded that the cell phone was not associated with increased risk of a brain tumor. Does that sound like an observational study or a designed experiment to you? Just without me even telling you what those things mean. Observation. They took a group of people, but then all they did was watch those people. They didn't say you have to talk on your phone for 3 hours a day and then I'm going to watch what happens to you. They didn't control anything else. They just took a group and they watched them and saw what happened. So this is an example of an observational study. And that's basically when all you do is sit and watch. So the second scenario. This time we have researchers examining whether chronic exposure to RF radiation at 2 common cell phone signals caused brain tumors in rats. So the rats in group 1 were exposed to the analog frequency, the rats in group 2 were exposed to the digital, and the rats in group 3 were controls and had no radiation exposure was done for 4 hours a day, 5 days a week for 2 years. And otherwise they were treated the same. So at the end, they analyzed the data and found no statistical significant increase. So is this observational or a designed experiment? Designed experiment. They took them, they split them into groups. They said you're going to get this type of radiation, you're getting this type, you're getting nothing, you're getting it for so many hours a day. So this is a designed experiment. So what we are doing in both of these scenarios is looking at how if you vary the explanatory variable, it affects the response variable. So those are a couple terms. I don't know if I put those on your term handout. I did. Okay. So we need to kind of figure out what those things mean. An explanatory variable. That's the thing we control. It's the thing we're changing. And the response variable is what we measure afterwards. So looking at our examples, the explanatory variable, what was the thing that they were controlling or looking at here? Right, the cell phone frequency, right? I'm just going to put the level of cell phone usage. The explanatory variable, that's the thing you were studying. The response, what were they trying to look at as a result? Mm-hmm. Okay, so I just wanted to kind of take those terms and apply them to the examples that we looked at. So the explanatory, that's the thing you're manipulating to get some kind of result. And the result is your response variable that we're looking at. So, if we haven't defined observational study and designed experiments, so let's go ahead and do that. In an observational study, you measure the response variable without attempting to influence it in any way. You're just measuring what happens. You're not making any changes to it. In a designed experiment, you manipulate the explanatory variable and then record the response. So you are making some kind of manipulation there and then seeing what happens as a result. Which one is better, do you think? it depends on the scenario. You know, in general, in an observational study, you have to be careful. If I want to, I don't know, let's say I'm going to teach an online class and I buy a new textbook for them and I want to see if that textbook is better. So I just give them their textbook and then I compare their grades to your grades at the end. And your grades were higher, so I assume that book is worse. Why is that not a good idea? Okay. Is it the same to do it in person and online? No. Am I guaranteeing that their ability level is the same as your ability level to start with? No. The problem with an observational study is there's a lot of other variables that could impact your results. So you can observe what happened, and I could say they didn't do as well, but do I know for certain it's because of the book? No, I don't. In a designed experiment, I would do something way more thought out. I might take, students with the same GPA and put them in the same class and give one book and one the other book. So I'm trying to minimize those other variables that impact them. So you have to watch out. Now, is it always ethical to do an experiment? If I want to see if your phone causes a brain tumor, is it ethical for me to sit here and say, you have to talk on your phone 6 hours a day? I'm going to see if you get a tumor or not. No. So you can't always do a designed experiment. That's why we have observational studies. But in general, if you can do an experiment, it's better because you have more control, so you're more likely to know why you get the results you get. All right. So let's see. Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors age 65 and older. Researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get the flu vaccine, and Group 2 chose not to. After observing them for 10 years, it was determined that the seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. So is that telling me that all seniors should get their flu shots?
No.
Why? They got it and they seemed healthier than my other group.
100% guaranteed.
Okay. They were divided into two groups. Was anything else controlled outside of whether they got the flu shot or not? So maybe the people that got their flu shot were also the ones that tend to go to the doctor when they get sick. And they got treatment sooner when they were sick, so that they got over it and they got medicine and didn't end up in the hospital. So it does not guarantee anything. Maybe they're more health conscious and they eat better and exercise, and those things could all have a role in it as well. So we have to be careful about our conclusion. We can say what percentages we found. By the way, if I just list those percentages, is that descriptive or inferential? Descriptive. I'm just telling you what I found. Now if I said, if you are over 65 and you get your flu shot, you will be 27% less likely to be hospitalized for the flu. Would that be descriptive or inferential?
Still descriptive.
It would be inferential if I was trying to extend it to everybody. I could say in my group, this is what I found. But trying to assume that that would be true for all, the entire population, that would be making some kind of assumption. So that would be inferential. All right. So let's talk about some of those issues. Confounding is when the effects of two or more explanatory variables are not separated. So the flu shot and how much they exercise, those could be confounding variables. I can't really separate which part of it was because they got the flu shot and which part of it was because they regularly exercised. And so that's blurb under there. You don't have to write that down, the therefore portion. That's just saying that we can't guarantee that the response we saw is because of the explanatory variable. A lurking variable is another variable that we didn't even consider. Okay, so something I never even thought about, but it could affect the response variable. So maybe the group of seniors that I picked, maybe there were a large portion of them that had never even gotten the flu. And that wasn't something they were typically susceptible to. You know, it wasn't a variable I considered, but it would have an impact on my results. So confounding is when you have two variables and you can't really discern what's caused by each. A lurking variable is something you didn't even consider that changes your result. The last term I have on here is a census. So a census is just a list of all the individuals in a population along with the characteristic of each individual. So let's say I was looking at GPA. A census for the high school would be if I printed off every student in the high school along with their GPA. So a census is just a listing of everybody, just like the census, it's counting everybody. So that is actually the end of section 2. I think I'm going to stop here and then we'll cover sections 3 and 4 tomorrow. And you guys all have a Chromebook, right? So tomorrow is supposed to be an online learning day. So in all of my spare time, I'm going to at some point make a video for the next part and you will watch that tomorrow. But I am going to go ahead and give you some homework and you guys have time to start right now. So for the section 1, page 11, we're going to do 8 through 40 even. It's not as many as it sounds. It's one word answer on all of them. It's like parameter, statistic, descriptive, inferential, those types of things. And then for section 2, we're going to do 9 through 14. On problem 19, I only want you to do B through E.